Hey everyone, and welcome. Today, we're diving into an incredible story where medicine and pure engineering genius come together to solve a problem that, not too long ago, was basically unfixable. It's all about a critical artery and the brilliant way surgeons figured out how to repair it from the inside out.
Okay, so let me ask you this. Imagine you're in charge of a city's water supply. The main pipe running under the busiest street is about to burst. It's a catastrophe waiting to happen. But here's the catch. You can't just shut off the water. The whole city needs it. That exact problem, that's the dilemma surgeons face every day with the body's main artery, the aorta. So to really appreciate just how amazing the solution is, we first have to get a handle on the problem itself. And it all starts with a very dangerous bulge forming in that critical pipeline. You can think of the aorta as the absolute superhighway of your entire circulatory system. It's the massive vessel that carries all the fresh, oxygen-rich blood from your heart out to the rest of your body. And just like any highway, it has these crucial exits. These are the smaller arteries that peel off to feed your most important organs, like your kidneys.
But here's where things can go wrong. Sometimes, the wall of this highway can get weak and start to bulge out, kind of like a weak spot on a tire. In medicine, we call this an aneurysm. And the danger is huge, because if that bulge gets too big, it can burst. And a rupture like that is just catastrophic.
So, here's the million-dollar question. What on earth do you do when that ticking time bomb, that aneurysm, is located right where those critical exits to your organs are? You can't just put a simple patch or a sleeve over it because that would block off blood flow to the kidneys or other organs. It seems like an absolutely impossible problem to solve.
But faced with what seems like an impossible problem, surgeons and engineers came up with a custom-fit solution that is, well, it's nothing short of brilliant.
And the big idea? It's actually beautifully simple. Instead of trying to fix the weakened pipe from the outside, the idea was, why not build a brand new, stronger pipe inside the old one? And here's the genius part. You build that new pipe with perfectly placed, custom-cut holes that line up exactly with those organ exits, keeping the blood flowing just where it needs to go.
Now, the official name for this procedure is a mouthful. FBEVAR. That stands for Fenestrated and Branched Endovascular Aortic Repair. The key piece of tech here is something called an endograft. It's basically a tube of fabric that's supported by a metal scaffold, or stent, and it acts as that new inner pipe. And get this, the whole thing is inserted through a tiny incision, usually in the groin.
To create these perfectly fitting devices, surgeons have a whole toolkit of design features they can use. It's really like a bespoke tailor, crafting a suit to fit one person's unique body perfectly.
First up, you've got the simplest tool, the scallop, and it's pretty much what it sounds like. It's a semicircle cut out right at the top or bottom edge of the graft. Think of it like taking a scoop out of the edge to make room for an artery that's sitting right at the end of the repair zone. Simple, but effective.
Okay, stepping it up a notch, we have the fenestration. This isn't just a notch on the edge, it's a precise, circular hole cut right into the middle of the graft's fabric. It's often reinforced with a little metal ring, and it acts like a perfectly placed porthole that lines up exactly with an organ's artery.
And then, for the most complex situations, you have the branch. Now, this is way more than just a hole. It's a whole separate, smaller fabric tube that's actually attached to the main graft. It literally extends out from the main graft and into the target artery, creating its own dedicated little tunnel for blood flow.
So you might be asking, which one is better, a fenestration or a branch? Well, the truth is, it's not a competition. It all comes down to the patient's unique anatomy. A simple fenestration might be perfect for an artery that comes off at a nice clean angle. But for trickier angles or longer distances, a branch might be absolutely necessary. Both are crucial tools in the surgeon's toolkit.
Of course, something this precise doesn't just happen on the fly. This kind of surgery requires an incredible amount of planning, down to the last millimeter, long before the patient even comes close to an operating room.
Surgeons actually have a few different ways to get the right device. For a planned surgery, they can order a fully custom-made device, which is built from scratch for one specific patient, but that takes 6 to 8 weeks. Now, in an emergency, a skilled surgeon can actually modify a standard graft by hand, right there in the hospital. And for more common body types, there are even some ready-to-go, off-the-shelf designs.
And the entire process, every single time, starts with a super high-resolution CT scan. Using very specialized software, the surgical team creates this perfect 3D digital blueprint of the patient's aorta. They measure every angle, every distance, even the exact clock face position of where each artery comes off.
It's all about designing a graft that will fit like a glove.
So the procedure itself is just a masterclass in precision. It all starts with that 3D blueprint. Then, the custom graft all collapsed down is guided up through an artery in the leg. Next comes the really delicate part. The surgeon has to carefully rotate and position that graft until every single hole, every scallop, every branch lines up perfectly. Then they deploy the main graft and finally place smaller stents through those openings to lock everything in place.
So after all that incredible high-tech work, what does it all mean for the patient? Well, when an experienced team performs this procedure, the results are an absolute game changer.
Let's just look at the data for a second. In one of the major studies for these devices, the technical success rate, meaning did they get the device in place exactly as planned, was, get this, 100%. Every single time.
Okay, that's great, but what about the most important number, patient safety? Well, in that same study, the 30-day mortality rate was just 1.5%. For a procedure this complex on the body's largest artery, that number is incredibly low.
And to really put that number into perspective, just look at it compared to the alternative, which is a massive open surgery. The short-term risk with FBEVAR is significantly lower. It's just a crystal clear win for this less invasive approach.
And the benefits don't stop there. Because you're avoiding that huge incision, recovery is dramatically faster. In that same study, the average hospital stay was just over 3 days. I mean, think about that. A major repair on the body's main highway, and you're home in just a few days. That is simply incredible.
You know, this whole thing really makes you wonder about the future. We've just seen how custom-tailored engineering and 3D planning can completely transform one of the most difficult operations there is. So it begs the question, as this technology gets even better, more powerful, and faster, could we be looking at a future where every surgery becomes this personalized? It's a pretty powerful thought to end on.